Bismillahirrahmanirrahim. I thought I would do an example to illustrate how we graph this trigonometric functions, which is the present focus of our discussions. So this is a good one I found. Y equals negative 2 times cosine of the quantity 2x plus pi plus 1. So this is a cosine function that we are asked to graph over here. And to graph these functions, you have to know some fundamental things. And the first thing that you have to know is the basic graphs. So they are very similar or analogous in their structure in the anatomy to, if you recall, the quadratic functions like this. Okay, that's the parabola, of course, and nearly all the functions that we have studied kind of are parallel, in at least in the form, in this form, the vertex form, the parabola. So we've studied, for example, the sine curve. I have given to you the general equation for the sine curve, which is a times the sine of, I'm going to highlight this b over here, and x minus vx plus vy, and then the cosine general equation for the cosine curve, a times cosine of b times the quantity x minus vx plus vy. And if you recall, we found the period of these trigonometric functions by dividing 2 pi by this b over here, and that's why that b is so important. Okay, so that b is, that's a busy b, so that period is very important. That's 2 pi or b. Let's get this correct, shall we? So, all right, there we go. And then, so you have to understand what a does to the function, what b does to the function, what this does to the function, what this does to the function, to be able to graph these, correct? And also, you have to kind of know the basic shape of these curves. So y equals sine of x. So if you were to graph this over here, the parent equation, y equals sine of x. And the period would be 2 pi, and it looks like this. Remember, the first half of the graph is like this, crosses there at pi. The second half of the graph is like this. And then if the basic cosine curve starts over here, and then those are the critical points. It goes to half over here, goes across over here, takes a turn, cosine like this. So that's y equals cosine of x. Now you have to know these parent functions, and then you're going to manipulate these parent functions to be able to draw graphs like these. Okay, so you have to know. Now if you observe over here, okay, the way I draw this is I kind of like, first thing I like to do is find this rectangle where this graph is going to be circumscribed about. I mean, the graph is going to fit in that rectangle, right? And this is the period of the graph, right? So that's the period from here to here. That's the period. And that's going to be determined by 2 pi divided by that b, right? And this point right here, okay, right there, that's the pseudo-vertex, right? Vx and Vy, so to speak. Pseudo-vertex is the beginning point. And that point is going to be shifted to whatever is determined by these numbers over here, right? So the pseudo-vertex. So once you have this table determined, this rectangle placed in the graph, then it's easy to graph the function. And then this, of course, is the amplitude of the function right here. Okay, so the amplitude of the function is determined by this a over here. So the amplitude is from here to over here. So the amplitude of the function Okay, it's actually like the absolute value of A. Okay, it's like the height of the A. It's the absolute values of A. So that's the amplitude. So we know how to find the period. We know how to find the amplitude. And these would give us the horizontal and vertical shift. Now, observe, dear students, look at this. In this example I've given you is y equals negative 2 times cosine of 2x plus pi. Whereas there's the coefficient of the x is actually 1. So sometimes you factor out, you have to factor out that to bring it into this form over here, okay? So the first thing we need to do in order to graph this function is to bring it in this form here. So I'm going to do that. So negative 2 times cosine of, pardon me for a second. So that's negative 2 times cosine. I'm going to factor that 2 out, okay? So if you factor that 2 out, you have x plus, what is it, plus, what is it going to be here? Pi over 2, because, you know, if you factor out 2, you know, so if you were to distribute this, see, you'll get that, okay? You'll get this. So I factored out the 2. Now I have my function into something that I can recognize. So this is A, that's B, and that's the Vx over here, and that's the Vy. Okay, so now let's see. Let's get to it then. Now we have recognized that the amplitude here is going to be 2. Okay, we got that. That's pretty easy enough. And well, let's stick to our color codedness. The amplitude is going to be the absolute value of 2. That's 2. That's the height of the graph. All right, and let's do the period. Shall we do the period? Okay, so the period is going to be 2 pi divided by this 2 over here, 2, and that's going to be pi. In other words, this graph is going to do a circle. I mean, do one cycle in pi instead of the usual. It's 2 pi. This is going to be a busier graph. Okay. And now look at this. The Vx, so to speak, is going to be what? Right. It's going to be negative pi over 2. It's going to be moved this way because it's negative over here, right? So this graph is going to be moved to the left. And the Vy is 1. It's going to be moved vertically 1. So this graph, which would have started right here at the origin, it's going to be moved this way because thanks to the horizontal shift. Okay, so the graph that would start over here, then this is a cosine graph that would start over here. It's going to start right there. The whole thing is going to start right here. So if you allow me, I'm going to kind of like put in my box first, okay? So let's add this to color here. So this graph is going to start here, like there, okay? And its period is going to be pi. So I'm sorry, it's going to be moved pi over 2 right here, okay? So if you want to make that bigger. So instead of starting over here, the graph is going to start at pi over 2 for there. Okay? So we got that. Okay, now, and then I'm just going to make that with red. How about that? It's going to be shifted this much, okay? And then it's going to shift up by 1. So instead of starting here, it's going to be shift up. So let's call this 1, 2, and 3 over there, right? So let's just call that 1, 2, 3. So this is 1. So instead of starting, the whole graph is going to shift up 1. So now this is kind of like the new x and y axis right there, see? And then the amplitude is going to be 2, okay, which means that this is 1, 2, 3. So the amplitude is going to be 2, so it's going to be from here, that's 3, and it's going to go down to 1 to over here. So the amplitude is 2 from here. Okay, so that's 2. and that's 2. Okay, so that's the amplitude. So, and that's going to be like -1 over there. Okay, and then the period is going to be pi, right? So we have to rectangle this thing. So it's going from -2, this is half a pi. So it's going to go over here to pi over 2 over here. That's going to be the other end. Okay, so our graph is going to fit in right in here. You see that? So what did we do over here? So we figured out the shifts first, okay? It shifted -pi over 2. It shifted to the left, okay, by pi over 2. So it's just starting here, we're starting over there, okay? And then it shifted up, so instead of starting here, it started over there, okay? So this became kind of like our new starting point at this, right? That's the new intersection x-y axis, okay? And then we determined the period was here, right? Here's pi, so we went from here to here, okay? And then we knew that the amplitude was 2, okay? So this is the amplitude. That's A, absolute value of A, and that was determined to be 2. All right, we got that. Now let's graph it. Shall we do it? So now let's graph. Now this is a cosine curve, right? So we're going to look at the parent curve like this. That's that curve. But then it's -2, so it's going to be flipped. We're going to start the cosine curve. We're going to flip it. So it's not going to start over here. It's like a flip hammock, right? So it's going to start over here. Now if you notice in the parent graph, I divided the 2 halves, right? Like that. Okay. So same here, we're going to divide it into 2 halves like this. So it's going to start over here, right? It's going to go to this point, climax over there, and come down over here, and it's going to end up over here right there. Okay? Now, whoever was on the hammock is long gone, right? So the graph, therefore, is going to look like this. The graph of this function is going to go look like that. So you can see how easy it is once you kind of find that rectangle where to graph this in, and like this. And that is the function. Now if you wanted to, this is just one period, right? If you wanted to, you could make another period, you know, like this over here. Keep going, right? Like over here. And then keep at it, right? So it's like, it would be like go to here, come down over here. It becomes quite easy to do it either way. So, and I'll just make it more definitive. This is kind of artistic version. Hopefully your graphs look a little bit better than mine probably are. And like this. I think I got this. Yeah, I have to make sure. Yeah, you gotta be careful. See, I made a mistake here. I went through here. I'm supposed to go through there. So, but that's cool. And then come down here, ta-da, like that. Not too bad. So that is the graph. So this is the graph of a function over here, y equals -2 cosine of 2x plus pi plus 1. And we factored this out before we did anything into a more recognizable form like this. Okay, so what did we learn from here? We learned the general equation for this trigonometric function is y equals a cosine of b times x minus vx plus vy, and this gave us our amplitude, and this gave us our period. Sometimes we have to factor out that b to make it look like familiar, and this was a horizontal shift and this was a vertical shift, and that was reasonably, hopefully easy. Until next time, assalamu alaikum.